This conference will now be recorded.
All right. So what I'm going to discuss today, very few people joined. One second. I want to club actually other people. By mistake, I told them the session timing is at 8:30 instead of 7:30. Okay, no worries. So this is what the architecture we have discussed today, and we are going to focus on this Azure Synapse because the first data will come to this storage account, and once the data is coming to this storage account, inside we have created a blob storage. So once the data is coming to this storage account of the blob storage account contains 4 different kind of storage modes. Correct? Storage account contains 4 different kind of storage modes. Out of these 4 storage modes, one is a blob storage and the second one is a table storage mode. The one we have a blob storage and another one is a table storage. So whatever the files, the incoming file from the business, it might be a structured or unstructured or semi-structured. All the files, structured means contains like a proper format like rows and columns, and unstructured means like audios, videos, images. So these are all the some unstructured files. They don't have any kind of structure over here. Semi-structured means like XML, JSON files. So these are all the files we have, XML, JSON files we have. Okay, structured, unstructured, semi-structured. All right. So this is how we have a data available, different kind of data available in the blob storage. So as a part of our project implementation, the first data will come to the storage account, that is a blob storage, and the next one is a table storage. Next one is a table storage. Table storage is going to store the data in columns and rows. So whatever the data the business filed over here, uploaded over here, whatever the data the business uploaded over here, that data we need to load into either Azure SQL database or Synapse data warehousing. So let me take this Synapse data warehousing. What is a data warehousing? Data warehousing concepts, if you want to understand very clearly, there are many things you need to understand. The data warehousing means a lot of years of historical data we are going to maintain over here. What is a data warehouse? Data warehouse stands for years of historical information. A lot of years of historical information will be stored on daily basis. So a data warehousing contains dimensional modeling. Dimensional modeling contains dimension tables and fact tables. What is a dimension table and what is a fact table? And also the way we are creating the relationships between the tables is called star schema or snowflake schema. Alright, so along with this we have some other concepts of the data warehousing. If you want to understand very clearly about this data warehousing concept, what you need to do is you have to, I will give you one video over here, so you just follow that video to understand this one. Okay, so I will share that one. This one. So in this video I have explained very clearly about what is a data warehousing. AWS, Azure, and in the sense, for example, if you are going right and get values, and so I have explained very clearly how the data will be stored in your SQL database. From there, when you are coming to the data warehousing concepts I have explained very clearly. The data warehousing concepts are very important. The data warehousing concepts are very important whenever you are going to work on any ETL or any reporting tools. So that's the reason I'm going to give this video to you, so to understand this one. So I'm just pinging in the chat. Take that video by everyone. So in this video I have explained very clearly about what is OLTP, what is data mart, what is ER modeling, what is primary key, what is foreign key, what is OLTP, what is data mart, what is ER modeling, what is foreign key, what is foreign key, and what is master table, what is a transaction table. These are all one level. And then next one is what is a data warehousing, what is data warehouse, and what is data mart, what is a dimensional modeling, what is dimensional modeling, and what is a dimension table, what is a fact table, what are the different kind of dimension tables available. So what is a star schema, what is snowflake schema, what is snowflake schema, what are the different kind of dimensions, and what are the different kind of measures, what is a surrogate key, what is the difference between star schema and snowflake schema. So whether you are learning the Azure data engineering or whether you are learning AWS data engineering or any Power BI or any other reporting tool, regardless of the tools, these are very common things you need to understand. What is a data warehousing? What do you mean by warehouse? Generally, if you are storing many items in one place, that is called a warehouse. Similarly, what we are doing daily, the business people daily uploading the files into the storage account of the blob storage. So that data we are going to transform by applying some data factory transformation techniques or Databricks ETL. By using these tools, we are refining that data and loading into the Azure Synapse data warehousing. The data what they are going to keep inside this blob storage is a raw data. It's not refined data. It's not refined data. That is a raw data. So in that kind of situations, you need to refine that data and apply some transformation techniques, and finally loading the data into Azure Synapse data warehousing. Azure Synapse data warehousing. Clear? So we are going to load the data into data warehousing. To load the data into data warehousing, you should have a database, you should have some tables, and how the tables created, what is the relationships between the tables, and how the data modeling happen. Data modeling means creating a tables. To create the tables, what are the columns, data types, relationships between the columns. So all those things we are calling it as a data warehousing, sorry, data modeling. Creating of the tables, making the relationships between the tables, and organizing the data inside those tables is called data warehousing. Alright, it's called data warehousing. Okay, so I'm requesting everyone, please watch this video before you are joining tomorrow's session. That will explain very clearly all these concepts. This is a common topics for everyone. In future also it will help you. Even when you are going to the interview, even in our book also we have included this data warehousing concepts, questions. Okay, in our book also we have included this data warehousing concepts. Okay, all right. Okay, so now what I'm going to do, we are going to create data warehousing. So data warehousing is going to contain some dimension tables and fact tables or whatever it is. For data warehousing storage system, definitely if you want to store your items, you need a warehouse. Why we are using this Synapse data warehousing? Why we are using Synapse data warehousing? Earlier we are calling this as a Synapse data warehousing, but now they have changed this name as a dedicated SQL pool. The name has changed from Synapse data warehousing to dedicated SQL pool. Dedicated SQL pool. So let me log into this dedicated SQL pool. Let's see in the Azure portal, azure.com. Simply go to the sign in. Then you can sign into this and skip for now 14 days until this is required. Click on this Azure portal. Log into this portal. Okay, so here you can search for the Synapse data warehouse. Do we have anything Synapse data warehousing? No. That name got changed to dedicated SQL pools, formerly SQL DW. That name got changed to dedicated SQL pools, formerly SQL DW. Dedicated SQL pools, formerly SQL DW. So simply click on this one. So what is the specialty of this dedicated pools? Any specialty? Yes, it has a specialty. If you observe the architecture of this Synapse data warehousing, this is a very important interview question. Architecture of this Synapse DW. we need to understand some concepts inside this Synapse architecture. What is a control node? What is a MPP? MPP stands for Massive Parallel Processing Engine. What is a control node? What is a massive parallel processing engine? What is a compute node? What is a DMS? Nothing but data movement service. And what is a control node? What is a control node? What is MPP? What is compute node? What is DMS, data movement services? And what is a distribution methods? There are three different kinds of distribution methods: round robin, hash, and replication. Okay, so let's say, for example, in this Synapse data warehousing dedicated SQL pools, I'm going to create a table. So this is the architecture. So this is my dedicated SQL pool, SQL data warehousing. I'm going to create one table. The table name is DIM customer table. Okay, DIM customer table. In this DIM customer table, I have a customer number, customer name, and customer pin code. So this is the information I have stored inside this one, and let me enter the data as well. 100 RAM, and the pin code is 24567. 200 Sham. This is another pin code. 300. This is the pin code. 400. This is the data I have. So whatever the data I have, this data, by using a reporting tool or any application or any tools, we are trying to query the data. Let's, for example, this is a Power BI. Power BI is a reporting tool. Power BI is a reporting tool. Then I want to query this from Power BI to whatever the data I have in the DIM customer. I want to query the data in Power BI because I want to design a report. Total how many number of customers we have. Okay. So the moment when your Power BI wants to query the data from this DIM customer table, how it is going to perform this one? Your Synapse having a control node. So your Power BI or any applications first will contact the control node. First it will contact the control node. From this control node, then it will take the request. What is the request it has sent? The request is select star from dim customer table. From the customer table, it is trying to query the data over here. It is trying to query the data from customer table. The moment when you are sending this query to the customer table to the control node will take the request, and that is going to send this query into MPP engine. Control node is a brain. How a human brain will work, this control node also will act like a brain in your Synapse data warehousing architecture. So it will send the request to the MPP engine. MPP stands for Massive Parallel Processing Engine. MPP stands for Massive Parallel Processing Engine. Select star from dim customer. Select star from dim customer. MPP stands for Massive Parallel Processing Engine. What this Massive Parallel Processing Engine will do? This is going to split your query into multiple smaller queries. That is going to split your query into multiple smaller queries. Means instead of performing a work by one person, if the same work has divided into multiple persons, if the same work has done by multiple persons, then you can able to finish that as early as possible. Correct? Similar concept over here. The massive parallel processing engine also will do the same thing. The task, whatever the assigned by the control node, will be split into multiple tasks, and it will split into multiple queries. It will split into multiple queries. Whatever the queries it has split into multiple queries, then those queries will be executed on different compute nodes. Each compute node will execute one query. So the maximum number of compute nodes from 0 to 60. What is a compute node? Compute node means it's a kind of a virtual computer. It needs to execute your query. Definitely it needs some CPU, RAM, all those things. It needs some CPU, RAM, all those things. So whatever the CPU, RAM, memory we have over here, so that we are going to make over here each compute node having some compute infrastructure. This is compute node 1, compute node 1, and this is compute node 2, this is compute node 3, so this is how we have different compute nodes available. So what will happen? The query will be split into multiple smaller tasks, and each query, small query, is going to execute on the different kind of compute nodes. So what the queries will do? The queries are going to take the data from this dim customer. Let's say for example, this dim customer table contains 100 rows, 100, 200, 300, 400. Similarly, I have almost 10,000. How the data will be distributed among multiple compute nodes? how the data will be distributed among different compute nodes, because 100 rows needs to be distributed, right? Whatever the data you have, some records needs to be queried by this one, some records needs to be queried by this one, some records needs to be queried this one, some records queried by this one. Then finally all the data whatever queried by different compute nodes will be combined again over here. Instead of querying the all data by one query or one compute node, we are performing the task by distributing the data for multiple compute nodes. For multiple compute nodes. Clear? So how the data will be distributed? Out of 100 rows, which row needs to go to this compute node? Which row needs to go to this compute node? So the data distribution method will be defined based on this. The moment when you are going to create a table, create table, dim customer, customer number, integer, customer name, varchar, and pin code, varchar. So you need to define with distribution. What kind of distribution? If you are specifying round robin at the time of creating this table, that at the time of creating this table, we are defining the distribution method. If I am specifying round robin, how the 100 rows what you have in this table will be distributed. Or else, for example, you have 4 rows you have. How these 4 rows will be distributed? This row will go to this one, this row will go to this one, this row will go to this one, and this row will go to this one. Again, the next row will go to this one. This is how data will be distributed randomly. Okay, data will be distributed randomly. Data will be distributed randomly. Record by record, record by record will be distributed. The default distribution method on a table is, if you are not specifying any distribution method, default it will take round robin only. Out of 100 records, it will split it into one record, 1, 2, 3, 4, 5 until 60. Again, it will start 61, 62, 63, 64 until again 120. So this is how record by record, record by record will be distributed to multiple compute nodes. So that is called one distribution method. Sometimes what will happen, I have a huge volume of the data. Mostly the fact tables contains more the data. Create table, fact, sales table. Sales tables contains a lot of data. Customers, hardly in my business I have 10,000 customers. But in the sales table, those 10,000 customers are doing so much of the sales. That kind of situations, like I have a order number, integer, and quantity, integer, sales amount, integer, and also I have sales order year, integer. So what I want to do, I want to distribute this data. I have almost 10 years data. From 2010 onwards, I have 2021 sales order year 2010 to 2021. Order year 2010 to 2021. So 2020 to 2010 to 2021. Now I'm going to create a distribution method with distribution equal to hash and what column? Order year wise. What is this meaning? When you are doing this distribution on the order year wise, the data will be distributed all 2010 data into one compute node and the order year 2011 data into one compute node and 2012 data into one compute node. This is how it is going to distributing the data based on the values by grouping the similar values into one group over here. Okay, whatever the column you are specifying over here, based on that column it is going to split the data. So mostly round robin is recommended for the tables with the less volume of the data contains dimension tables. What are the best examples for what is the best example for the dimension table? The dimension tables are customer tables and product table and geography table. These are the tables. And hash is recommended for huge volume of the data, like fact tables. Fact tables means like sales tables. And the replication strategy, how the data will be distributed. Replication, when you are going to use a replication on a table, the entire table will be distributed into each compute node. So I have 4 rows. 4 rows will be distributed to this compute node. 4 rows will be distributed to this compute node. 4 rows will be distributed to this one. So mostly we are using this replication strategy on a lookup tables. Create a table, city, lookup, like city code, that is like an integer, and city name, varchar. City code and city. Okay, because I have a city code like HYD, that means Hyderabad. City code BNG means Bangalore. Sometimes we need to use this lookup table to compare the data. To compare the data, we need the city table. So by using this city table, these kind of lookup tables are recommended to less volume of data, like a lookup tables. So this is the architecture. We are not going to do anything. I just want to give you how internally it will process. We are not going to perform all these compute nodes or control nodes. We are just creating a table, and when you are querying the data, this is all about the internal functionality. This is all about the internal functionality it will happen. Okay, so why I am telling this Synapse data warehousing, then why I am telling this Synapse data warehousing is, after this Synapse data warehousing, I am going to teach about the data factory. So the scenario what I am going to use in the data factory is, I have a blob storage, nothing but a storage account. This is my storage account. This is my storage account. Inside this storage account, I will create a container. Yesterday we discussed about what is a container and what is a blob storage. That means uploading of the files like emp1.txt, emp2.txt, emp3.txt. So I will upload the files into the storage account. Daily business people will upload these files, or my HR will upload the employee information. Then what I need to do, I want to load this data into the Synapse data warehousing. Contains some tables like employee, dim employee table. Dim employee table contains employee number, employee name, salary, all those things. So how can you perform this? By using data factory. By using Azure Data Factory or Azure Databricks. So to discuss about this Azure Data Factory or the Databricks, definitely we should aware of this storage account and this Synapse data warehousing. Correct? Azure. This Synapse data warehousing is something similar like your SQL only. How we are using a SQL server, same thing, 100% same. Only the difference is in the backend, this architecture, the way it is querying the data is different. This is more faster comparing to our normal SQL server. This is also a SQL server platform, but in the backend, the way it is querying the data is a bit different. Okay, a bit different. This is querying the data in a bit different process. That is the reason I am explaining today and tomorrow about this Synapse data warehousing. This is also very important in interview point of view. In the real-time scenario, definitely we are using this storage account to upload the files, and whatever the files you uploaded, that data I want to store into this Synapse data warehousing. And to perform this ETL loading, we are using Azure Data Factory or Azure Databricks. So once the data has loaded into Synapse data warehousing, then Power BI will come to the picture. So then Power BI will come to picture and connecting to the Synapse data warehousing, and Power BI developer is going to design the reports and dashboards. So the overall data engineering course is main focus on this data factory and bricks, ETL, and to perform this ETL, we need a source and we need a Synapse data warehousing. The sources might be a storage account or it might be a data lake. We will discuss about this data lake as well. And the destination might be a Synapse data warehousing or it might be a Azure SQL database. We will discuss about the Azure SQL database as well. So first we will focus on these two things. storage account, Synapse. Sometimes instead of storage account, we will use Azure Data Lake. Data Lake also similar like your storage account. Azure Data Lake. Here also we are uploading the files. And this is also Azure SQL. This is also something similar like your Azure Synapse Data Warehouse. Then again we are going to use Data Factory or Databricks. Once the data is loaded, then we will focus on this Power BI. Clear? This is what we are trying to understand over here. I hope understand everyone. So I am requesting everyone by tomorrow, whatever this video, I will share this class notes as well. This video again I am pinging in the GoToMeeting chat. Please take it from the chat. Please watch this video to understand the concepts of the data warehousing thoroughly. And tomorrow I will show you how to create this dedicated SQL pool, how to create a tables as well. Then we will jump to the data factory. Okay. Any questions from anyone? All right, guys. Let's meet on tomorrow. Thank you. On the same time.